Okay, let's take a look at section 9.5 on space figures, volume, and surface area. First of all, we have a box, sometimes referred to as a parallelepiped. And as usual, my pictures have not transferred, so I'm going to do a rough sketch here. Okay, so we have a box that has a height, a length, and a width. The volume is found by multiplying the length times the height times the width. Surface area, we have length times the width would give us top and bottom. Length times the height would give us the two sides. We do have two sides, one we can see on this face, and then one on the back side we can't see. And then finally the ends of the box, which would be here where I'm putting an X, would be the height times the width. There's one we can see, and then one at the back again we can't see. So that's volume and surface area of a box. Primarily this section is formulas, and you just plug the numbers in and solve. Next we have the cube. And these are a little bit out of proportion, and I apologize for that. Okay, there we go. And for the volume, we just multiply side times side times side. You'll note with a cube you have 6 sides, which are all squares, and the surface area of each square is s squared. So the surface area is 6s squared. A right circular cylinder, looks like a can. And on this we'll have a height, and we'll have a radius, and the volume is pi r squared h. Surface area is 2 pi r h plus 2 pi r squared. The 2 pi r squared would be the surface area of the circle that makes up the top and the bottom that we can't actually see. Okay, the 2 pi r h comes from the rectangle you get when you slit this down the side and unroll it. You get a rectangle that measures h by the circumference of the circle, which is pi r h. I'm sorry, 2 pi r. Okay. And so we end up, when we multiply the two, we end up with the rectangle has an area of 2 pi r times h. So okay, next we move on to the sphere. And the sphere has a radius. Use little r since that's what they use. And the volume is 4/3 pi r cubed. Surface area is 4 pi r squared. Okay, a cone has a height and it has a radius, and the volume is 1/3 pi r squared h. So it's 1/3 the volume of a cylinder of the same height, and the surface area is pi r times the square root of r squared plus h squared plus the area, the surface area of the circle that makes the bottom. So pi r squared. A pyramid may have different types of bases. It could have a base that's a rectangle. It could have a base that's a triangle. It could have a base of another shape. Okay, mostly we're talking about a square, I guess would be the other one we would talk about. So, and again, it also has a height, h. And what we do is we find the area of the base using the appropriate formula. If it's a triangle, use the triangle formula. If it's a rectangle, we use the rectangle formula. If it's a square, we use the formula for a square. And then we take the volume, and we don't have to do a surface area, thank goodness for this one. Will be 1/3 the area of the base times the height. So depending on what we have, we use the appropriate base formula. It's going to be either triangle, excuse me, rectangle, or square. So you need to select the appropriate one. Okay, so the next thing to do is watch the sample problem.